Alright, good day everyone. So for this presentation, we'll discuss about the forward linkage and how to find the extreme positions of a center line or a link in a forward linkage. Right, so I will also show you a demonstration how to find the extreme positions. Okay, I will use an AutoCAD today for the demonstration. Okay, so let's go back to our uh, to the topic about the forward linkage. So for forward linkage, it consists of a line of centers between the two axes of the cranks, two cranks and one connecting rod. Alright. So for this demonstration, we will solve the problem 1-1. So for this problem, there are two axes Q sub 2 and Q sub 4, which are fixed. Q sub 2A is equal to 1.5 inches. AEB, or the connecting rod, is 3 inches. Q4B is equal to 2 inches, and the line of centers Q sub 2, Q sub 4 has a length of 3 inches. Crank 2 is the driver turning counterclockwise. The proportions are such that while 2 makes a complete revolution, 4 oscillates through a certain angle. So we are required in this problem to find the two extreme positions of the center line Q4B of crank 4. Alright, so forward linkage. Alright, so given this has been done given the dimensions. Okay, so the length of Q sub 2 is 1.5 inch, AB is 3, Q sub 4B is 2 inches, and the distance between the two centers Q sub 2 and Q sub 4 is 3 inches. Alright, so we are required to find the two extreme positions of Q sub 4B. So Q sub 4B for the crank 4 and its extreme positions is our point of interest in this demonstration. Okay, so first is we will have to determine first if what is the direction of the revolution of the crank 2. So it is given here that crank 2 is the driver and it is turning counterclockwise. Hence, it will turn going to the left, right? And we are given also that if crank 2 makes a complete revolution, crank 4 only oscillates through a certain angle. Alright, so we are given here it implies that crank 4 is longer than the crank 2. Okay, so first is we'll have to project the circle of revolution of the crank 2. So first here is that we'll have to make a circle with the center at Q sub 2. Okay. Alright. We'll have to transfer first the A. Okay. Alright. I think it's not in the center. This will make another circle. Okay. Okay, next, then put in the right. So this circle is the circle of revolution for crank 2. So it means that point A, that this circle is the path for point A. Alright, since it's given here that it makes a complete revolution while point B only oscillates a certain angle. Right. So next is that since this it completes a single revolution, it means that it completes 360 revolution. So at this point, we may decide uh, when we decide at what interval should we assign for crank 2. One may decide if the interval is 10 degrees, 15 degrees, or whatever interval you may use for the revolution. Right. So for this demonstration, I will use 15 degree of interval between the position of the crank tube. Okay. So our next step here is to do an array. So do an array. So we'll select the crank including the point, and make an array it throughout 360 degrees. Right. So we'll select these objects. Right. So this is a polar array, so we have to uh, select the center point of array. So the center point of array is the center of our is the axis of the crank, right? We'll select the center of the crank use something, and now this is the point we'll be deciding on how many items should we use for the array. So for here is that since we use a 15 degree interval between the positions, so we'll have to enter here the angle between. So it is 15 degrees, right? Next that. So I can do manually. Manually rotate here so that we will complete the area of the whole revolution, right? Next. Okay, that's it. So we'll have an array of the home position of the crank tube in one single revolution. Okay, so upon checking here, we can say that the interval between these positions is 15 degrees, right? So we have checked here that the interval between the positions is 15 degrees, right? So after that, we'll project the path. We'll project the path for point B, right? So we'll make a circle, and the center of the circle is the axis Q4, and we'll have to project that to point B. Okay. So this is only a projection since we know that point B only oscillates a certain angle, and since Q sub 4B is longer than Q sub 2A, so it indicates that Q sub 4B only oscillates, and the shorter one, the Q sub 2A, which is the driver, is the one that can complete a single revolution. Okay, next, we have to project the points. Okay, we have to project the points of the positions of the crank tube uh, throughout or including the whole 4-bar linkage. So from here, this is our next point. So we'll have assigned here as another point A. So for this, since it is another point, we have to reassign this point as A prime. Alright? So this is A prime, so since this is another position of for point A. Okay, so we have to project. Okay, so we have to project this connecting rod here if it touches the path for point B. So we have to assign this for easy, so that we can distinguish this from another object as another color. So we may use a yellow color so that we can identify this path with another objects. Right. So next is, we know that the length of point AB is 3 inches. So you have to project a circle here. This is our center circle. and with a radius of 3. Right, so 3. Okay. Next, so you know that the distance here is 3. So next step is to draw a line between this point up to the intersection of the path and the circle that we have just made, a circle of radius 3. Okay, after that, we can delete this circle, this imaginary circle. Okay, now we have another point here, which is another point B at the second position of B. Now we can complete the forward linkage at this particular position. Alright. So we have to assign this another the second position of B as B prime. Alright, B prime. Okay. So we now have the second position of the forward linkage after an interval of 15 degrees. So we have Q sub 2, A prime, B prime, Q sub 4. Okay. So for some of those that are not they're still not using AutoCAD right now, you can do a projection here by uh, using your compass. Same with compass with here, you can do an array here, 15 degrees interval between the positions. Then for the projection of, and also with for ground 4, so we can you can project a circle here with given the size, given the dimension of ground 4, and for the on how to do the projection for A prime, B prime, you just have to use your compass by projecting a circle, also projecting a circle. Then it's the center. This is the center. Is this second position. Now project in the is circle of radius 3 inches. Then project here. So the intersection, you just have to locate the intersection there. Then you have to assign it as point sub B prime. Okay. For the next positions, what we're gonna do is just we'll just have to repeat what we've done with A prime B prime. Right. So we continue doing this for the next points until we complete the revolution for Grand 2. Right. So we're gonna do a nice project another circle of radius 3. Right. Next, we draw a line between the intersections. Right. Next, same with the another point. Okay. For this stage, as you go along with projecting the another points until you complete the revolution, it may be confusing. So it depends on what style or what way you're going to prevent confusion. What I do is that uh, as soon as I get a projection, I immediately draw a line between them, such as because of these positions, the uh, the projecting line in the path for point B will get steeper, will get steeper. Thus, it will be more difficult to find those projected lines in those intersections. All right. So as soon as you get a projected circle and it intersects with point B, you just have to simply draw a line in between those points. Okay, this, so we just have to repeat this. Right. Okay, so you might have observed here, might have observed here that we have two intersections between the projected lines and the path of point B. So obviously, what we're gonna select here for in projecting the line is here. So yes, in the second quadrant of the circle, right? So not this, but this. Okay. Right. So we have just completed the projection of the of the lines of the connecting wire AB into the current 4, into the path of point B for the current 4, right? So we just have to complete assigning uh, the points of the several positions of point A. Okay, so we'll just have to simply copy these points, right? So the preceding points of the positions of crank 2, we'll have to adjust to assign them collectively as A prime. Okay, so we have multiple points of A prime here. Alright, so we just completed it. Okay. So for the next step is in order to complete uh, the several positions of the 4-bar linkage. Next is we will also assign the intersection at the path for the point B. Right, so we just have to copy here these circles. Okay, any all the intersections. Right. Alright, so I think we have already found all the intersection at this side. So next is for the other side of the crank 4, right? Right. So same with point A, we just have to copy the B prime for all the other positions of point A, of point B, and all right, point B prime. Okay, yes, that's all. Uh, then we can assign all these points as the 16 positions. I mean, the several other positions of point A, another color so that we can distinguish it with point A. Okay. All right, same with point B. So here, we also have to assign another line type for our projected lines. Projected lines, alright. So for here, we may assign here a line of a dash line. So here, I just have the line type here. So for the depository of AutoCAD. So we have to find the dash line, right? So this is our dash line. Okay, so we have to load here. Okay, so select these projected lines, assign as dash. Okay, so I guess I will we'll change the scale here. Okay, the scale, I think that's alright. Yeah, okay. So all these projected lines, except the original position, will be assigned with, alright, will be assigned as a dash line type. Okay. I guess we can do a to match the properties here. For in assigning for a line type for these lines, you may use using this toolbar dash line, or if you have already assigned uh, a line type for a single line, you just have to simply to use the command in a or match prop, so you can have to so you'll be able to match the properties of this point with other points you intend to have the same properties. Okay, here, so I just did matching the properties here. Right, next here. All right. Okay. Next, uh, next is we have to project the line for the line for uh, uh, line Q4B. Right. I think we'll have to return this unit. All right. Next, so project all these lines to the center of Q4. All right. Center, center. Okay. So we just simply have to repeat what we did with uh, in the second position of point B. All right. So we have just completed projecting all the positions of the whole bar linkage. Okay. I think we have not yet much about here. All right. Okay. So we are required. If you take a look, at the positions, the several positions of the full bar linkage, so we can see here that uh, crank to complete completed a single revolution, while the crank 4 is only oscillating uh, with respect to axis Q4, right? Okay, so from that, yes, we can locate the extreme positions of the graph 4. So we just have to simply locate these 2 points, and thus the 2 points, the farthest points between the several positions of point B will be our extreme positions. Alright, so before we do that, I will have to do some trimming here. Okay, in order to do that, you just have to type TR in order to trim. Okay, okay, so you have trim. Alright, okay, so first is that we have to locate farthest point for B5. So in order to easily locate here when getting the extreme points, you just have to assign this. I think we can involve in we can involve in this. We can change the thickness of the line, right? So over here, just we change some splitting here for the line. Okay, all right. Okay, for the line, change line here. Okay, okay, all right. Yes. Then assign this to another color. All right. So next is we have to find the farthest position at the leftmost of the graph 4. Okay. So this, yes, this is the farthest. So we have to assign this with another color and thickness of same with what we use. Okay. So what we just use here. Okay. Yeah. This is a little bit thicker with what we used here. So we just have to do a matching of the properties. Okay, match the properties here, then copy this here. Alright, so I guess they are now of the same properties and thus the same thickness. Alright, next, since we have to trim, so we have to trim this part. So this is not significant with what required of this problem. Just have to simply trim this. Alright, trim. Okay. Alright, and we want to delete this point. Okay. Same here. So this is center. Okay. Then next is that we have to embolden this path so we can easily distinguish the whole path of point B, or the circling path of point B. We can do a matching properties here. Okay, this, this, alright. Right. So this is our final version here. Okay, so for this problem, we are required to find the two extreme positions of our center line Q4B, okay, for the crank 4. So from the original position, so we have to draw the these, okay, sorry for that. Okay, so from this original position of our linkage, given the dimensions, so we did a projection of all the points of the forward linkage. Okay, given that the crank 2 is the driver and it rotates uh, or turning counterclockwise. And we know that crank 4 is longer than crank 2, that thus as crank 2 makes a complete revolution, this crank 4 only makes or oscillates through a certain angle with respect to Q sub 4. So by this, we were required to find the two extreme positions of the point B. Now, after doing this procedure I've just demonstrated to you, so we have found the two extreme positions of the point B, and we assigned these extreme positions as B prime and B prime. So this path, this bold line yellow is the path of the oscillation of point B. Okay. Then from this, yes, we can measure, and yes, we can measure what is the angle of oscillation of the point B. Okay, so we have to locate these two lines of these two positions. Okay. Okay, so it is 100. Okay, 100 degrees. Okay. So while so if we have to turn activate this forward linkage. So for a complete revolution of every complete revolution of current 2, we can say that point B is oscillating with a maximum of 100 degrees. Alright, so we have just since we have just measured the angle between the inflection points of point B. Alright, so that is all for now for this topic about getting the two extreme positions of in a forward linkage. Okay, for clarifications and questions about this topic, just contact me and you may ask questions to our consultation period or through the communication channels that we have just discussed, and yes, you already know about those communication channels. Okay, so see you for in the next lecture and next topic, and goodbye.